All right, again, these are going to be posted online. Okay. All right, so I gave out new cheat sheets. These are a little bit better than the ones I gave you in the first week. Okay, so they're a better version. In fact, online I uploaded this new version. And then page 2 is the opposite. The first week we did derivatives. This week we're doing integral. So I'm going to give you a warm-up problem. Oh, here you are. Thank you. Yeah, no problem. Okay, we're gonna start with a warm-up problem. I want you to get up on the board for this warm-up problem. So here we are. Here it is. Give me the derivative of this function. Here. There we are. Go ahead and get to work. This is going to be your task. So based on just like the cheat sheet I gave you, Jesse, that's go ahead and just come up with the solution for this. Any whiteboard space, you can grab a whiteboard next to Deja. You can grab one of those big ones too, right next to you, if you want. You can put it on a desk. You can do whatever you like, right? You can work with each other. I really don't mind what you want to do. Okay. No, sorry. Why'd you write pi? Pi over 2. Wait, you wrote pi. So then pi should be over here because this is x. That's an x. That's an x. Oh, okay. Not pi. Change that. Yeah, sorry about that. See, you confused me. If Ben is giggling, then he sees something. Okay, ask him what he sees. Like, what do you see, Ben? What are you laughing at? Did I do it? I think it's still 1. Oh, it's 1? Yeah. Still 1? No. Because of the rate of x. Yeah. You can just imagine it. That's the 1. Those are nice. Bless you. This is the one in the first one. Oh, that's yeah. Guys need a little bit more time. Yes. 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 Is it just okay, would we like to see what the answer is for this? Yes. You guys ready? Okay, let us see what it is. I believe the answer is let's see. Anybody get this final answer here? Yeah. Okay. Let me walk you through this really quick. All right. So I'm going to start doing like steps, formal little steps here. I'm going to say step 1 is to define first here. Well, actually, let me write up the problem and model where I'm going to get the formula from. So in order to find the derivative of inverse sine of whatever term that you have, okay, you simply plug it into this formula. We went over a brief proof last week or week 1 about how these formulas are achieved. Okay, so it's not completely unintuitive where they come from, right? You just have to prove it to yourself. But if you had to memorize it down to brass tacks, okay, it's just going to be 1 over a squared minus x squared, knowing that your term is technically x over some constant a. Okay, again, that constant is a. So in this case here, let me write down the general formula once more. X over a is equal to 1 over a squared minus x squared, and you take the square root. Okay? So in this case, let's pretend that I don't have the solution here, right? Let's first define your u and your a. What is your u? What is the u? Your u is x, and then what is your a? Yeah, it's just the constant 2. Okay, so if you're going to plug it back into the equation, so that's step 1, is to first define what you have, the terms, and then step 2 is to plug it back into the general formula for the solution, which is this right here. So sorry, step 2 is going to be 1 divided by the square root of a squared, which is 2 squared, minus u squared, which is x squared. And your final answer should be 1 over 4 minus x squared with respect to x. Okay? Sorry, there you are. Okay? And that's how we achieved that.
Would you not
Go ahead.
I was just confused.
does it reduce down to 2 minus x in the bottom because the square root, or just leave it?
Oh, right here?
Yeah.
2 minus x, you said?
Yeah.
Not necessarily, no. That would not reduce. So it's not like, let's see. It would be like saying, let's try and prove this to ourselves here. It'd be like saying that this would be equivalent to 9 minus, let's say, 4. Okay? And you're saying this would reduce down to what again? 2 minus x.
Oh, you can't, because you have to do what's inside, right?
Mm-hmm. So you have to first deal with what's inside. So initially you would just do 9 minus 4, and that'd be 5. But let's see if that's equivalent to if we did it the other way that you're suggesting. So if we took the square roots, that'd be 3 minus 2. And then if we take the individual square roots of each of those terms, that'd be 3 minus 2, and that'd be 1. And these are not equivalent. Okay? So just a brief proof. Okay? I could have given you a more extensive proof if I thought it out a little bit more and gave myself a little bit more time. Because it does take me a little bit of time, quite a bit of time, to get these things down. But yes. Okay? There we are. All right?
All right, but why does that formula even exist? Why is a squared? Why is x over a?
X over a here?
Yeah, why is that derivative even work?
We went over a proof. I don't quite remember what we went over exactly, detail, like note for note what we did. But yeah, we did. If you remember, we kind of broke down exactly where it comes from.
Ended up getting with the 1 minus x squared. We're gonna have 1 minus x squared.
Oh yeah, with the a, yeah. Actually, so you're asking where the a comes into play. That I can't really answer. I don't know. The best way I could say it is, I think there's situations where you have a solution where eventually someone found that you have a solution that's not always a numerator of 1, or let's see. I don't think this is a good example, but I think with like a cosecant. Like they had terms on the numerator that were not necessarily 1, as like the other formula that you saw included. So they had to find out a way to make this formula work to where any constant on top of the numerator can be considered back into the original term that we were taking the inverse cosecant or inverse trigonometric function of. So in order to do that, they found that it's whatever the x variable was divided by some constant. So to make all these things a little bit more robust. So that's the best answer I can kind of give you. I prefer to answer where the root and the origin of where they found that or why. I can't exactly go that far yet. So that is my limitation in answering your question. Okay. All right. So let's move forward now, because this was a review of what we learned in the first week. How about if I asked you to do something else? What if I asked you to do now, let's take the integral of 3 over the square root of 16. Oh, a lot of you guys have already turned the page, okay? But you didn't necessarily need to do that. Oh, a lot of you guys didn't necessarily need to do that. You could have just used the front page and went backwards. But can you find the integral of this statement? 3 divided by 16 minus 9x squared dx. Can you find the integral for this problem? Okay. Now, this is something I did not go over with you guys. But based on what we already know, can you work on some inferences and some clues here, and the materials I gave to you, the resources to work backwards in order to go forwards? Who knows? You may use your cheat sheet. Sadly, you can't use your cheat sheet on the test or the AP exam, but you can do it in this context in the class. This is tricky. It's first hard to identify which trig function this is. Inverse trig function you would have to use.
Mr. Lee,
Yes.
can I get another worksheet? I can only open this.
Oh, all right. I'm sorry about that. That must have been out of frustration. Like, I don't like this, Mr. Wee. Forget it. It's okay. I mean, that's what I used to do when I was in high school. Like, if I don't get it, I get mad, and someone's getting yelled at. Except myself, yeah.
When you don't get a problem, who's mad?
Yeah, it was always everyone else's problem but my own. So it's like, oh, now it's everyone else's issue. I'm not gonna blame myself. Are you crazy?
Oh my goodness. I ripped a whole page out of the
My math book.
That was quick, right?
On accident?
Of course on accident. I didn't go like,
I
I don't want to do this, Terry.
I mean, I don't know. Tell me about me.
Okay. So let's see here. What solution did we end up getting? Which trigonometric function did we rely on, or did we kind of fall on here? Which one was it? Arc sine, inverse sine. And how were you able to determine that? What techniques did you use to be able to determine this? Out of these 6 trigonometric functions to work backwards from, how did you know it was going to be inverse sine?
Because of how it was set up.
Okay, like in what way? Like, how did you know? So let's define and work out loud and talk out loud. Exactly.
It's a constant minus an x squared.
So, okay, you have, in the denominator, you have a constant minus x squared, okay?
And the numerator isn't negative, so it's not something.
What's that?
And the numerator isn't negative.
Okay, the numerator
It's
is,
the
okay, all right.
the general function.
I see what you're saying. Okay, all right. The constant, I guess, in this case, is not being subtracted, so you don't have a negative number on the top. Okay. Also, what else did you say? The square root.
Square root on the bottom.
That completely limits it down to 2 different choices that we have here. Or if you even go back up here, in the very front, if you're trying to work backwards from all 6 trigonometric functions, you have 4 actually possible choices for this here, this here, this here, and this here, to where you could have a square root sign. But what makes it not the cosecant, the inverse cosecant in secant squared? What are we missing here in order for us to maybe utilize these inverse trig functions as the solution?
And it has something in the front, right?
It's a constant, right?
No, x.
Yeah.
Yeah, we don't have some kind of variable in the front at all, the square root sign. Okay, so we can eliminate these choices. Be careful of the negatives, having that negative sign there. That is kind of relative, though, depending on what constant you had in the beginning. So that isn't always the best solution. But here, let's see that. Well, I guess that is the differentiating. Yeah, that is actually a bad thing for me to kind of note out. I guess there's really not a difference. It is just separated by the negative sign. So I guess it is. Well, it limits it down to these 2 choices here. Okay. So we have a constant squared minus x squared. So in this case here, once we limit it down to these trigonometric solutions, your last case and the last thing that you need to do is define what your variables are. So I know it's really confusing because it calls these guys as x here, and then it calls these terms a. But on the sheet that I still have online, I'm going off the notation online. The only difference is that they kept everything in u, just to add to the confusion. And they have arc sine on top of that, okay? So what I'm about to do is I'm going to use u's instead of the x's, right? If that makes sense. So in place of all these x's, I'm just going to put u, right? If you don't have to do this, I'm just saying for today's purposes in my class, whenever I'm talking about this stuff, I'm talking about in terms of u. So this would be u, right? I don't know if that's going to add to more confusion, but imagine those as basic u's. So the reason why I say that is because in here, if I were to look at this here, I would define, my first step would be to define your u and a. I'm going to quote that. I'm going to say that u squared, in this case here, whatever has to be u squared is 9x squared. What would that make u then at that point? 3x. And then your a squared would have to be 16, right? Because that is the constant a squared, and that 16 acts as a squared. Then what would a be? 4. And then your final solution, you know that your solution is going to be in the form of sine -1 of u over a, I believe, plus c, right? Because we are finding the integral. And then you simply just plug in your values. What is it? Oh, and one more thing. We have to make sure that on the top. So again, this still isn't. No, I think this is good, right? Yeah, this is good. So we'll go back here, okay? So I apologize. These are all in terms of u, so I like this. Okay, so over here, you have to ensure that this over here, your du. So let's not forget about du here. What is du going to be as well? I'm sorry. So I totally forgot about this part. If you have u is equal to 3x, u squared is equal to 9x squared, what is du going to be? Is it?
Wait, I mean 3. Sorry.
3. You're correct. Yes. So let's back up. I think I kind of rushed this a little bit. Let me back up a second. I'm going to write out the whole thing. Sorry. So sorry. So what I'm going to write, what I want to write is this whole general expression. Just so I see how everything fits in, okay? A squared minus u squared is equal to, so once we figured out the integral for this, we find that the solution is sine inverse of u over a plus c. And now what we want to do, let's focus in on this now. I want to start plugging in the values and seeing if everything works out nicely. And back to what I originally had. Du should be 3. That looks good. And I'm going to rewrite this as a squared, so I know my a is 4. So I'm going to just rewrite that as 4 squared, okay? Even though it's equivalent to what I originally had up here, 16. I'm going to write this as 3x squared. You don't have to do it this way, but it really makes it clear where any missteps you might have taken or any errors might come from, okay? If you kind of go through it thoroughly, if you have the time, okay? And then inverse of sine, you know it'd be u minus or divided by a. And you have defined your u as 3x and your a as 4. Okay? And that is your final answer right there. Okay? So that's a nice thorough way of kind of going about this. So now let's explore cases. So this is pretty much what we're going to do for the day. We're just exploring different scenarios and different problems. Very common inverse trig problems. In fact, some, because it seems like we've gone to things that have been quite complicated, we're going to return to the basics too. It's going to kind of come full circle once we're finished with this lesson. Right? And you're going to kind of see what I mean. Because you're like, oh, I don't know how to solve this problem. And then the solution is going to be a lot simpler than you expect. Okay? So you're going to kind of see what I mean. We're talking on vague terms here, right? Okay. Where are we going? Okay. How about, would you guys want to do another one, or would you like me to show you this one? Another one? All right. Fair enough. What if I gave you this problem here? I asked for the integral. Okay? Go ahead and work on this now. Please get up on the whiteboard, guys. Yes. So I'm forcing you guys now to leave.
I'm sorry.
So go through it roughly. Try your best with a partner, okay? Talk to each other. And then at the end, I'm going to give you the formal steps to how to do this, okay? More organized steps in how to approach this problem. Be careful about picking the inverse trig function.
I'm not doing it. I don't like doing these things. Going straight line.
Yeah, so this.
So basically,
Whoa.
Oh, we'll just. It's just.
Let me walk around here. This one's a little bit trickier.
so it's a frame one, right? Yeah. Because this is like
How are we doing over here?
oh. Yeah, I don't want to.
And then.
Because then you can't all.
Okay, then don't look at mine. You want to work it out.
Oh,
You want to work it out.
okay.
Like he doesn't want to do this. He doesn't want to do pleasant child.
Ooh,
I know.
It's beautiful. Yeah, you can do that. That's the way that the math should be.
This is a short.
Did I do it?
No, I need this.
Wait.
Yeah.
Did I do it?
It's just like you're trying to challenge yourself. Then I'm okay. Tell me when you're done.
Good.
What do you do?
These are
Writing on the test.
Yeah.
This.
Oh, I
Yeah,
remember.
so the reports.
What did you define? So first define what you're doing.
Hey.
It's two addition words. So it's just the one. The A is just the one that doesn't have X.
Be careful. A is reserved for constants.
Oh.
Yes.
Oh, actually, except A is 5.
I mean, this would also
Oh, yeah, that's right.
How are they?
So the U goes in the top. So which one do you?
U is 2X.
Again, U is reserved for variables. A is reserved only for constants. Yes. That is correct.
So it's reverse for tangent, right? For which one's A?
Not necessarily. It's just because it's addition. You can order it however we want. So the A might be first. The U might be first.
Just put up A is equal to
U is basically
It's a mystery. Yeah, you would always.
whatever has X next to it, and then A is just a number of anything added.
I think you're whatever.
So the one without the X in the
Oh, it's a
denominator?
fifth.
Oh, okay, that makes sense.
You didn't.
Oh, yeah. I actually don't know how to do that.
Other, what's the other?
Like that is a strong word, okay?
That's what I used it,
kinda
Nathan.
cheated. I looked at yours. I got mine.
That's okay, I got mine. Honestly.
Oh, where did you get 5 from? Top here.
I multiplied this
So
by
you got penny
because
whatever penny.
wait, this thing is
What?
wait maybe
Yeah.
it should
I
be
usually see
there.
going
Just
with
kidding.
Originally just started with
Wait,
that.
this to be
Oh, okay. So then,
I have 0. My mom was yelled at me for using that.
So
I
if
think
I
it's
have
the
13
Because I've been buying
D,
stuff on top.
so that would be
Or
2.
like Apple lady.
And then this would
Really?
be
This
Yeah.
penny thing's gonna be
Yeah.
dumb.
She
I'm not
said
used to this
that
format.
her bill is a lot. The last one I
That's
got
not
was
the other
$4.
one. I mean,
yeah,
From like 2 weeks ago. $4 is like This is equivalent just having one on the top. So what if you just leave it in terms of one on the
You know what? I was thinking about you when I was there because the last time I went to Starbucks.
You should have EU on top.
This is
I
very
was
dividing.
this, I was this close to getting you some.
That's okay.
Write it down.
I'm just different method.
Because the formula says DU
Oh,
on
did it
top,
make you
so
all
wouldn't that be?
It is, only if you
It's not
define U
crazy.
as.
It didn't make me crazy. Did you feel it?
Yes. Do you like me?
yeah. So that means
P
you're-
would be. What is it?
Christina.
With respect to.
Where are you?
With respect to X. So
Mm.
what we'd be doing is
Gotcha.
U substitution essentially, where you plug back in. Let's see.
you're
I think I'm just confused.
Was it 11?
and negative
I thought it was like
1. 2X over 5.
Oh yeah.
Yeah, so that was the
Yeah.
VU is 2. Oh, I guess that should be a 10th instead of 1/5.
That's not what I was like.
I don't know why. Whatever.
Yeah, this is not a normal problem whatsoever. I think
For this class?
No.
What are you talking about? No, Christine, no one's coming. It's okay, Aaron. It's okay.
Are you close?
there's no 2 on top, so I think that's what he so the 2 gets cancelled out.
Oh, yeah, that's right.
Pause on you for a second. Because when you, I think I heard breakthrough with.
There's supposed to be a 2.
Yeah, that's very.
What do you know? He hasn't given it back.
Yeah, because now he's
I know, I know my
because he has.
I'm pretty sure
No,
he's.
because he doesn't have the strength.
Yeah. If anyone's correct, it's Ben.
Hey,
Like, I don't think like it's close.
He's gonna have because originally
That is the curve.
No,
It's the curve we all want.
Once you get back, like,
That's the thing, I don't know.
Like, it really is.
oh, I said off accident.
What if you go?
What is
So
that?
Ben, what if you go?
It does like a circle.
Straight.
How old are you?
14. Yeah.
Floor king. Oh.
I don't
So-
know.
Ben's
He was making
working
a
too.
face.
No, that's a great.
No, you're.
Oh, yeah, the integral sign.
I honestly
Do you know
thought.
what the word alcohol means?
What's your
What kind of
problem? Do
question is
you?
that?
No.
Oh, good answer, Aaron. Good answer. You asked dumb questions like that. You're gonna get a response.
That was a dumb question. How
Wait,
is it
but
a dumb
Are
question?
you a sophomore?
No, I'm a
Freshman. This whole time I thought he was like a junior.
Wait, you're in the same grade as Becky. That's what I just said. Nobody's listening.
I heard you, but I thought everyone else heard you too, so I didn't say anything.
Then?
Dad, just get Minecraft.
He's just shorter.
$7, but I guess he's.
Just because he showed her so much easier. That's
Yeah.
funny.
Like, 'cause I don't know, just something.
Oh, sorry guys. Give me a little bit of time.
So you know when you're watching videos with your phone, you have to hold it there. I can be really late. I can put the headset on and watch it.
Hang on. I know my samples.
It's like confusing to just getting it in the form.
Yeah,
It's like things are better.
Yeah.
Yeah.
It would
Get
benefit.
him all up.
I think you're absolutely right. I think I wrote something.
Slow down.
Sorry guys. Give me a second. I think I wrote something incorrect. No, nothing I gave out to you guys was incorrect.
Aaron, you just like plug it into the.
No, he doesn't.
Why?
It doesn't work.
Dude, huh?
The plugging in doesn't work.
I was trying
Yes,
to
it
say-
does.
No, it doesn't.
Did you do it?
Yes, it does. Yes.
Oh. What do you mean then? How
Have
did
you tried
Check your
it? Did you try to rip it? Okay, listen. It's 2 plus 2. What is
Yeah,
2
that's
plus
right.
2?
Yeah.
Derivative? Is that what you
That's
said?
the wrong
Omar,
derivative of the word.
Deriving.
Deriving isn't a word, right?
I'm pretty sure that's
Well,
not.
it's a word, but it's not the right word. Deriving, deriving is a function.
I just the right
It's
one.
not the derivative. Yes.
I mean, I got it mixed up because I didn't understand what each of the things meant. But yeah, you just plug it in. You just plug it in.
I haven't seen a problem like this, so I'm pretty sure someone just got some.
Did you? No. All right, y'all. Please sit down. Which one that works now?
Dude.
Alright, so don't worry about it. I'm putting you
You mumbling to yourself.
You're correct. Okay, so let's go through this together. So you might have ended up with 1/5 tan inverse tan of 2x over 5 plus c. That is incorrect though.
Is incorrect? I changed my.
Okay, hold on. Back up. Don't worry. I was going through the same struggles with you guys, okay? Yeah, Ben witnessed it firsthand.
Do you have an extra paper?
That's all I got, except one more. Yeah, I did. Sorry about that. Little tongue twister. So thank you, Ben, for pointing this out. And Omar, I like your blind allegiance. Just like, yeah, he's right, right? Not even gonna question it. Okay. All right, hold on. So first off, let's kind of go back rudimentary before we go on. How did you differentiate? So step 1, I'd like you to give me some tells. I call these tells for how to, let's see, distinguish. What? Distinguish that this was, distinguish between and a sine inverse solution to a tan. Okay, so first off, guys, hold on. How did you guys know that this was not going to end up as a solution for sine inverse, guys? How did you guys know that this was not going to end up as a solution? What things were you able to tell from here that gave away that this was not going to require a solution in inverse sine? Right, guys?
There's no square root.
Okay, there's no square root. So first step is there's no square roots in the denominator, right? No square root in the denominator. Okay. Okay, what else?
I'm gonna be honest, it's kind of intuitive. It just kind of.
What you mean?
You would just-
No, calm down, sir. What you mean?
Okay, in what way is it
Well, you
intuitive?
pick Which one? That part is like the first easy part. It's the
Obviously.
actual integral that's a lot harder.
Okay,
Like me.
I just on.
Are you just saying that it's easy just to pick which
Well,
thing it
yeah,
is?
I mean everybody.
That's
will-
true.
I thought you were talking about
He's right.
how mine was wrong.
I know, but I'm just saying. Hold on. I'm just saying. When you guys aren't gonna have the cheat sheet on the exam and you start mixing things up, okay?
Right.
If you had to remember a few key things, we remember that there's no square root. And what else gave it away?
Use flashcards.
That's a good one.
Is there anything else? Guys, is there anything else beyond the square root sign?
Negative, the minus.
Yeah, the a squared and the u squared statements are being added, okay? Or there's an addition of those guys, okay? So if you guys can remember it, no square root, an addition on the bottom of a statement that looks like you can take the square root of both of them, okay? That should tell you that you have to use an inverse trig function, and it's probably not going to be sine. So if you remember sine, the thing that really differentiates sine and tan, okay, the two most common things that come up on the AP Calc exam, right, if it comes up, right, are the fact that it's separated from a square root sign and it's not an addition, right? They're two very contrasted, different inverse trig function solutions, right? So that's how you can tell. No square root, and one is addition, the other is subtraction, right? Okay, so step 2, this is very pivotal because this is where it saved me from continuing down to make the same mistake I have been, right? Is to define your u squared and your a squared. What is your u squared, first of all?
U squared is 2x.
2x. Oh,
No, 4x squared.
it's 4x. Okay, your u squared, okay? So,
U squared. Oh, my bad.
you know what? I think it might be healthier to write maybe the general formula first on your paper. So bear with me. Hold on. I know it's very tedious, but you're going to see the value in seeing the tedium, right? If you're going to take the integral of a squared plus u squared is equal to 1 over a tan inverse tan of u over a plus c, okay? We want to write that down and see that for ourselves, okay? The next step would be to define what the u is, the a squared, the u squared, and the du, okay? So let's look at those things. So u squared, you said, was 20, or I'm sorry, it was not 25. By the way, why is it not 25? Some people made that mistake in saying that u squared is 25.
U squared can't be constant.
Can't be a constant. That's reserved for the a squared, okay? So u squared is going to be equal to 4x squared, making u equal to, what would that make u then? Yeah, 2x. And then the last step is your du. What is du going to be equal to?
2.
2 with respect to what variable? So we write that as 2dx. Be very careful. There is a very functional reason why I did that, Okay, so I'll come back to this. Yeah, it's implicit differentiation, but not only that, you're going to see why your answer is not 1 over 5 at the end. It's 1 over 10. Okay, so a squared is going to be equal to 25, making a simply 5. There's no reason why you should take a or dA because the problem never asks or never has dA, right? It only has these terms in here, right? Now think about this. All these things in here, okay, you're going to see back in the original formula, right? You see u squared, that's 4x squared. You see a squared, that's 25. You do see a in u, it's just hidden. It's like seeing it like this, right? It's like seeing, if we had to rewrite that, it'd be like 2x squared plus, that's your u, and then your a is simply 5 squared, right? But what is different? Does anybody notice anything different between what we have up here and what we have down here and these variables that we defined? Notice that up here, do we have a 2 up here in any form, shape, or form, like we do with du is equal to 2 dx?
We just solved for dx.
Yes, say that again.
We just solved for dx.
We solve for dx. So what this is going to look like, what that means is that I have 2 dx. I have all these things accounted for except that 2. So what we're going to do is we're going to set everything equal to just dx. So that what that's going to look like is du is equal to 2 dx. We're going to divide both sides by 2. And then what we're going to do is that in place of dx, we're going to put in du divided by 2 back into this formula. So what step 4 is going to look like is plugging it all back into this formula here. So what we're going to have is let's see, instead of du, instead of putting this in, we're going to put du up here, and then we're going to put 1/2 here. And then let's see, a squared is going to be supplemented in place with 5 squared plus your u, which is 2x squared. And then your solution is going to be as follows. 1 over 2, that's a constant value that we can't just leave out, times 1 over a, which is now going to be 1 over 5, times, or it's in front of tan, inverse tan, of u over a, u over a, and your u is going to be 2x divided by 5 plus c. If you look very closely, 1/2 times 1 over 5 is not finalized as an answer of 1/5. It's going to be 1/10, as Benjamin pointed out. Okay, good job. Does anybody have any questions? It's a very tough problem. It's not easy. Do you guys want to try another one? Okay, so let's try to go through that one more time. Okay. So let's see if I can back up here. Where was the confusion? Okay. All right, guys, go ahead and get to work on this. Okay, go ahead and work on this problem here.
Is that 3 plus 4 squared?
I'm sorry, what?
Is that 3 plus 4 squared?
Yes, that says 3 plus 4x squared. So be very careful. Your a squared is going to be a little bit more complicated this time.
So we'll have a radical then?
Yes, you will. And you don't need I'm not going to be strict in saying that you can't have a radical in the denominator. That would further complicate things. So for the purposes of this, you can totally end up with an answer with the radical on the bottom. Okay? I have one more mega type of problem. I don't know how else to describe it except mega. That's not formal in any way. Let's just say it's a very tough, challenging problem. So, Christina, in case you missed out too, because you had to drive. I changed the makeup for the percentages in the class. I'm going to put an even higher emphasis on test corrections. So, a quarter of your grade is now on test corrections. Yep. So let me grab that too. These test corrections are, I think, tough, and some of the way I gave you partial credit, I've changed already in the last few nights, looking back on the solutions. Okay. So what I'm going to do is I'm going to have a study group session, and also the test corrections is not due at the end of the month.
Oh, okay.
So I'm allowing a lot more time. Like I said, I think it's just as important to go back and really restudy what the heck just happened on the exam, with a little bit more time, a little bit more quality assurance to go back and be like, I don't know. So that's why I'm putting a much higher emphasis on test corrections. Okay. But I am making it due at the end of next month because it's right before the AP exam. So I don't want you to do it till the end of the semester where you never learn a thing from it. So, and what I'm going to do is maybe this Friday or next month in one of the study group sessions, I'm going to have a day where we just do test corrections and go through like the toughest problems where I don't think
that would be really helpful, I think.
Yeah, because I think some of them were just insane. So they're just really hard. And also, like I said, some things I've already caught. I'm like, you know what? Instead of giving partial credit, I'm going to give full credit if they came up with this answer, even though I marked a bunch of people wrong. So that day when you bring in your exams, I'll be like, did anybody not get credit for this that wants credit now for this or something, okay? And then just bring your exam and I'll make adjustments and I'll put them in the grade book that day. It's going to be a pretty hands-on day.
Thank you.
Yeah, no problem. So just letting you know.
No, everything else is the same, but I just
Answer his question, Nathan.
What's up? Oh, sorry. That's his question.
What's the short word? Oh, actually, yeah, you can.
You thought she was talking to you?
Yes, I
She was
I thought she was.
Yeah, so
I say that's a joke. That's not a joke.
It literally makes a lot more sense.
Why is it mathematics?
Miss, did you say garage or garage?
I don't believe.
What?
Okay, so you know the thing that comes down when you park your cars. Okay, do you call it garage or garage?
I know you did.
You're asking me if I pronounce
How do
it.
you pronounce the word?
Garage. Yes.
Okay, are you serious?
No, I don't. I say garage. Yeah. I say garage. Yeah. I just want to throw you in for a loop there. So, yeah.
That's the
Okay.
only really thing I can tell you from preliminary school and secondary school.
I didn't know that.
I didn't hear what you said.
Sit.
And
Did I do it right by the way, Mr. Reed?
What did you get?
I think you got it wrong.
That's mean, but yeah, you got it wrong.
I think I got it right then.
Dang, Deja, you were just like.
Or I got it.
Yeah. Whoa, yes. Oh, you nailed it. Yeah, that's it. That's right on. You're good. Dang, that was really
Did
good.
you just not leave
Did I get it right?
Wait,
Yeah.
you said we can leave the right.
You got it.
Objection.
No,
Yeah.
that's not what I did. I just
But that's not what you got wrong, though.
But technically, that isn't the right form. You got two things wrong.
Well, I did give him leeway, Deja, to just you can leave the radical in the denominator. I told him.
Oh yeah, last week, huh?
Yeah. But still, yeah, he is still missing something.
No, but you said that we should get in the habit because you had like
I know.
foreign professors or whatever.
I know, but just
Why is that funny?
it's true. It's just saying it out loud again. It sounds kind of crude. Just
I
like,
remember. I have a good memory.
you do.
Well.
Yeah, you pick up on the little details. I gotta be careful because
Because there's an 8 there. So the du was 2x. You have to multiply that by 4.
du over 2.
Because there's 8 here.
Right,
Two
but
times
it has
4
a
is
here, and it says that
No, but that
is
doesn't. You have to change this so
You
that
have
it's the du
dx.
of this.
2
So
Do you- yeah.
basically, what
Oh,
it
got
needs
it,
to
got
be,
it.
it needs to be 2.
Where'd you get the red here?
Do you guys want me to go over this now or no?
I put
Yeah,
in the
you guys are still discussing?
So then
Oh, you just multiply it by
Oh,
one.
by crazy.
we change dx to du.
I can teach it. I know it. I know it.
So then-
Yeah, Deja. Yeah, you are on fire today. Yeah,
No, very
calling people out left and right, picking fights with Ben. Come on,
So
Ben.
then if you divide by
Who's
2,
got the right answer now?
He's too like.
2, so it's 4
Yeah.
over
Yeah.
the
Careful there, yeah. Ben's not to be tampered with.
and then you take 4 out, and then you can multiply.
That's not how I did it though.
But hey, it still works.
Yeah.
Whatever method is, works, yeah. How are you guys doing over there in the table? Or, I mean, not the table, the whiteboard. You guys okay? They're lost.
Mr. Why'd you lie to us though?
You didn't lie. It's you substitution
And then
though.
It's a guideline, but there's still little details. That's why instead of just giving you the sheet and saying go home and you got it, I am here to fill in the little gaps where it's like the worksheet didn't necessarily tell me that.
This is more like a new substitution thing that we're doing.
No, it is. It's a little bit of a fusion. It's got the general formula, but you still have to do things through U substitution to make sure you're doing it right. So yeah.
If it was 8, and if u was 8x, then
Right, but the original problem gives
a
the top bit is du.
All right, guys, go ahead and have a seat. And why don't you guys have a seat? I'm gonna go through the solution right now. Okay. I love the discussion you guys are having. This is awesome. I love it because there's so much. There's debate. There's I don't know what's going on.
One thing.
There's motivation. I like this. Okay, so step 1. So I'll say step 1 is you don't have to. So last time I said to go through the tells, but you don't have to give me the tells, like the things that you were able to do to identify that this was going to be a tan inverse solution. Okay, I think you know by now there's no square root sign on the bottom and they're not being subtracted by each other. Okay, so I think it's beneficial for me to go back and rewrite this on my own piece of paper. The solution should be that if you have a statement that looks something like this, a squared plus u squared is equal to 1 over a times tan inverse of u over a plus c, okay? Once I've determined that this is going to be the general solution, this will be the general solution, but I'd like to see how this looks set up. It might even be beneficial for you to even write what you have right now, right below, because I don't know what it's going to look like, okay? You can kind of compare and contrast. And then in step 2, let's define your u square, your u, and so forth, okay? So your u square should be what? What is your u squared? 4x squared, making your u 2x. And one step further is what is your du? 2dx. Now, if you compare that in place of what goes in for du, be very careful. Okay, so I think you guys are looking at the same thing and maybe interpreting it slightly different ways, okay? They're very closely related. But look, we would expect in place up here, the numerator to be 2 and dx to the right. Okay, so, sorry, I will write that the answer, or this problem has dx in here, okay? Remember, there is a dx to the side there, okay? All right, that's not written very well at all. Let me make it clear, because you're like, I don't know what he's doing anymore, okay? There's a dx there, and I'm asking, just like in the original problem, there was a dx statement right next to it, where it's all with respect to x, okay? And I have 2dx, but that's a problem, because I don't have 2dx up here. Not exactly, okay? So I'm going to come back to that, and then let's keep defining our other terms. A squared is what? What is a squared?
3.
Very tricky. Don't make it 9. It is what it is. Your a squared is 3, making your a actually the square root of 3, okay? So let's see what we have here. Now, again, I would like to rewrite this again, this time actually in place of just saying straight to my a squared, I'm going to write it like this. In place of a squared, I'm going to put the square root of 3 being squared, okay? Like I actually take my a and then square it. Does that make sense? Just so I can kind of see logistically where these numbers are coming from, okay? And then my u will no longer be written as 4x squared, but the actual u, which is 2x, being squared, okay? And here is where I'm going to put in place of du, I'm going to put what I got, 2dx. The dx is over here, but how can I adjust to make this back to look like 8? I have 2dx in place of du, right? Du, I'm supposed to replace what I got. I got 2dx as my du, 2 and dx. But my original problem had an 8 in the numerator. So what does that tell you about the solution to this problem?
You have to multiply it by 4.
You had to multiply it by 4, meaning in the very beginning, there is some constant 4 just lying there, right? So what we can do is we could separate this 4 and put it right in front of the integral. Okay? So the 4, that's where the 4 is, right? And we'll keep it there for now, okay? Because we know that all these products and all these numbers here are directly involved in how it's going to be integrated when you're taking the anti-differentiation. But the 4, however, had no place. It was just a constant from the very beginning. Nothing's going to happen to it when you take the antiderivative, okay? But the 2 and everything else are directly connected, so they have to stay within the integral statement here, okay? So now I can write the solution. Going back to my general form, so I'm sorry to keep going back and forth. It will make more sense once you do more of these problems, okay? It's not as hard as I'm making it out to be, okay? The 4 stays in the very front. But now I can finally focus on the solution piece, which is 1 over a, and now I can finally plug it in. 1 over a will be 1 over the square root of 3, okay? Times tan, inverse tan, of my u, which is 2x, divided by my a, which is square root of 3, plus c, okay? Making my final answer 4 over the square root of 3, inverse tan of 2x over square root of 3, plus c. Okay, that is your final answer. All right, very tricky. All of you guys were pretty much at a 50% mark or above for where your answer was going. Okay, so give yourself a lot of credit. These are not easy questions. Okay, but it's just that last piece that makes it all the more difficult. Okay, these things always throw us for a loop. Right, this is what makes calculus very tough. Okay, so be proud of yourself for getting this far in calculus. It's so hard. Okay, one other thing. Huh? This is calculus AB, my friend. Yes. But take in consideration, too, the way I'm going about it. Some other teachers, I think their calc classes might be easier in some way because we're trying to go through it with a little bit more depth, okay? With just a little bit more. So we'll see how it works out in college. That's the ultimate result. Like, was it worth it to go through with a little bit more rigor or was it not? Okay.
So do you want us to tell you?
Yeah, actually tell us. Mr. Wee, no.
Okay.
Email, response, no. Oh, all right. The title says no, so I know where this is going. Okay. Also, one more thing. Just no. I'll know what that means. Okay. One other thing I told Deja, and I told you guys in the past, I said for the context of this question in this class today, I don't want you to worry about the square root being on the bottom and having anything to do with that. But when the time comes for the exam and you want to look for multiple choice problems, there is a good likelihood that this might not be one of the choices. Only because in classical math, you don't ever leave square roots on the bottom, okay? So I'll accept this answer. This is fair. No big deal. However, just keep in mind that there could be a possibility that the person writing the exam or coming up with the problems will not accept that as the final answer, but indeed will say there cannot exist a square root in the bottom, okay? So what they're going to say is you have to multiply both the numerator and the denominator by root 3, making your actual final answer. Don't change your notes. Keep it the way they are, okay? But you can add this, okay, if you want. It'll be 4 root 3 over 3. And then you have to do the same thing over here. You have to multiply at the top and the bottom by square root of 3, making this a final answer of 2x root 3 over 3. Okay? There is a possibility for that. Okay? I just didn't want to do that because that adds even more confusion to what we had to do today. Okay? But in all honesty, that could be an answer. Right? You might have a final answer with root 3 over 3. Okay. I thank you guys for this, all right? For being so patient with me. I'm not finished, okay? That was a maniacal laugh on my behalf, okay? Because we're going to go further and further down this rabbit hole.
Are we gonna do integration by
How's the other?
this year?
Yes, we are.
Is that next month or is that this month?
Oh, integration by parts where you're separate, like, well,
Not like the separation of variables, but like the one where you have like multiplication. Yeah.
well, I have so I said the next question was going to be the mega, but it's not. I realized there's one more question between there. I'm going to have to make a slight little 15-minute video for the last question, okay? But here is the in-betweener, right? The in-between question. What about the integral of 8x over 3 plus 4x squared? This is slightly different. I love it, Nathan. No, I'm asking you right now. Go ahead and try to figure this out. Did we? Did we?
Would you just add again?
Huh? I don't know. This one, I'm not expecting anyone to get. I expect 0 people to understand. Huh? Yes. No. Just go for it though. It might be a technique that you already know of, guys. In fact, let me be honest with you guys. There's nothing new. I'm sorry.
Yeah.
4x?
That's what I would think. Like in the last time I times it by 4, just times it by 4.
Okay, if you want to do that. Yeah, that might work actually. Yeah. Sure, yeah.
Because 8x is the derivative of.
And I just erased my answer and I totally forgot what I just did.
I feel like that has to be something, you know? Yeah. So I feel like I have 4x squared.
That has to be
So
something. You can just do it the same
figure it out. Well,
thing.
then figure now has to be the square root. U is now in the square root. Okay. The 8x is the derivative of 4x squared, is it not?
It has to be.
So that means that our u now is the 4x squared and the du is the 8x.
Hold on.
Let's do this. Exciting.
Squared is 4. Do you just multiply by x?
You could try that. I'm not going to say what you have to do. Just if you're really stuck,
Everything is the same.
try to rely on something that you've already done long in the past for integration. That's my clue. Because this is the fear of teaching you guys inverse trig. We've gone so far with derivatives and integrals of inverse trig, you might have forgotten what we call the basics. So that's all I'm going to say. Am I speaking in unnecessary, frustrating tongues? Or
Yes.
yeah, I am. Sorry. I totally am.
He's so far off the side. U is
Maybe not like you.
U is then
Well, I'm gonna laugh at
turn U into another b squared. Now dv.
Sorry, what do you think?
Oh, I'm doing something way beyond even myself. I'm not even
Then
understanding.
how did you do that?
Just going with this.
I have unfortunate news. It is 9:15, so I do have to call it
Just show us the
class.
answer.
Do you want us? Do you want me to show? Okay.
Don't show Aaron the answer.
Okay.
No.
First of all, this is not an inverse trig solution.
Wow.
No. Hold on. Yeah, I did trick you. I did trick. Hold on. Let me give you on. Hold on. Wait. The tell here is that you should not worry about inverse trig if you literally have a variable up in the numerator. That means that it requires a different solution. In fact, we were working backwards. On the exam, you would go for this solution first. What I'm going to describe you before you go to inverse trig. Okay, inverse trig is your last resort. Like, crud, I think it's inverse trig. I don't know. It's just something bad in me tells me what it is. Okay, but then you go for this one first. So we're actually working backwards. So the tell is that you have an x in the numerator, or a variable. Okay, but we're just going to crudely say an x in the numerator. Okay, and the solution, if you'd like to know, is just basic u substitution. What does that mean? Basic u
That
substitution.
means we have to find a u.
Yep. So you guys might have overthought this a little bit because, again, the fear with going through inverse trig was that you forget the basics, just u substitution. So let's make our u something in the denominator. What would our u be?
4x.
Or how about the whole thing? 3 plus 4x squared. Why not?
Oh, that works too.
Yeah, that works even easier, right? Because what is du?
8x.
Just 8x with respect to dx.
So it's du over u.
Yep. It's just going to be du over.
Yeah, it doesn't always work that way.
What the heck? So when does it work?
So ln 3 plus 4x
You
squared.
have to see what the actual u is.
So on. So what is the integral of 1 over u?
So it's natural log 3 plus 4
ln u.
squared.
Ln u
Okay, I said
plus c, and then u is just going to be.
Like 5 times. And then he asked the question.
No,
and then
I said- Aaron, let her have it. Let her have it.
Fine.
Let her have it. You guys all got it. Yeah, come on. No need to be frustrated, guys. But I love the emotion involved with these problems. It just means that you guys are motivated and you guys are into
I don't
this
understand where
material.
you can find your topic when you have to do it.
So let's see. So what are you saying, Nathan? Like where?
So you remember the last problem where I defined it as d equal to 8? It was like d equal to 2 instead, and u was 2x.
Yeah.
Wow.
When can you define the top as d
Thanks,
equal
I hate
to 8x like we did?
You're still doing it here. I just might not be consistent the way I write it. So
What does it mean?
You know what I'm saying?
so like
Saying,
I don't know. It's the weirdest
do we thank you for using purple
they're like
to
circular
grade my test?
colors,
That's my
right?
favorite color.
okay, all right, fair enough. Yeah, I'm happy to hear it. So you see how I just the dx over here to the side here, I just moved it up to the top.
Right.
So now once I find my du statement, I just make sure that du can replace all of this at the top.
Right.
Okay. The problem before was, so let me stop the video. Okay.